In extending our learning of linear equations, we're going to be also investigating some extensions, which scatter plots is one application of linear equations. So when we talk about scatter plots and lines of fit, what we're really doing is investigating and looking for relationships in data. So when we're talking about scatter plots, we're going to be using a particular kind of data that we call bivariate data. Data with two variables, two different amounts that we're collecting information on, that would be considered bivariate. And if you think about like the prefix bi, two, variate, relating to variables, so two variables. So when we look at a scatter plot, you may have actually seen graphs that look like scatter plots before. A scatter plot is going to show a visual representation of the relationship of bivariate data. So we graph that data as points and then look for a relationship. So you can see this graph on the right side here has the study time in minutes, looks like, for a particular quiz. So is there a relationship between the data? Well, you might guess that there was. You might think if you study more, you get a higher quiz grade. But if you actually look at the data and plot the actual information, each one of these points represents one person. So if you look at this particular point, it looks like this person studied for about 28 minutes. And their score was, it looks like, about a 74% on the quiz. This is not data from our particular any particular assessment that we've done, just so you're not concerned. But each one of those points represents an individual person's data, how long they studied, and then what score they got. So is there a relationship? Yes, and a scatter plot helps you more firmly be able to conclude that. So when we look at scatter plots, they show different types of relationship depending on what relationship there is between two quantities. So you can see 4 different types of scatter plots charted here, and they show different, what we call, correlation. So this first graph on the left here shows a positive correlation, and you should really make sure you get these sketches down. Shows a positive correlation. If you kind of think about this as a line, and we'll talk about the line part in a minute, if you draw a line in here, think about positive correlation also looks like it's also positive slope. So positive correlation, if it was a line, it would have a positive slope. Oops, slope. The next graph here we have is what we call a negative correlation. Sorry, skip ahead. A negative correlation, and if you notice, that also relates to negative slope. So when we look at positive and negative correlation, I wanted you to first see that like the names of them relate to the lines also. But if you take a second look at this also, when we talk about positive correlation, it's not just what does it look like on the graph that it's positive, but if you look at the relationship as the x values go up in this positive correlation, what ends up happening to the y values? Well, the positive, or the higher x values, are going down to the right here. What happens as x values go up? Well, in this case, because it's a positive correlation, increase in the x values means there's an increase in the y values. And I don't know why that's not showing up nice and clearly, but hopefully it's showing up okay for you guys. If you look at a negative correlation, as the x values are increasing, so increase in the x values, whatever's on the x-axis, you notice these y values are dropping. So in positive correlation isn't just positive slope. What that positive slope tells you is that there is what is called, and I'll go ahead and put it here, it's called a direct relationship. Meaning that as one changes, as the variable, whatever's on the x-axis, goes up, so does the value for the y-axis. So study time goes up, so does quiz grade. The opposite is also true, though. As your study time went down, what would happen to your quiz grade? Your quiz grade would go down. So you can kind of look at it as two different ways, but the direct relationship of a positive correlation means that X and Y kind of have the same relationship with each other. As one goes up, the other goes up. As one goes down, the other goes down. For the opposite, though, with a negative correlation, we actually call this an inverse relationship. So as one goes up, the other goes down. If you look at this third graph, we've got a lot of scatter. If I was going to try and draw a line to kind of explain where the overall trend is, there's no real trend here. This is a graph that shows no correlation, meaning that the data is kind of random and not necessarily all related to each other. And at this point in time, when we're talking about this fourth graph, there's definitely a relationship between the data. You can see these dots or these data points are grouped together along the way. But because it's not in a nice straight line, at this point I just wanted to show you this would be considered to be a non-linear correlation. We're not going to get very deep into this, but I just wanted you to see that just because it's not a straight line relationship doesn't mean that it's not related in some way. But this is definitely a graph where it's not going to be a straight line that explains how the data is related. So as far as evaluating correlation, if you're given a graph or given data, you want to know and explain what kind of correlation do you see and what does that actually mean. So for this example, we have hours of sleep and test scores. Hours of sleep on the x-axis, test scores on the y-axis. So this is the I do. You can think through this one and you'll get a chance to practice in a second. But if I notice my hours of sleep here and my test scores here, it's kind of, if I was going to draw in a line that kind of explains how most of the data is situated, it looks like it's going to be going to a positive slope. So this is going to be a positive correlation. What that means, and so when I explain the correlation in this situation, I want to explain what does it mean in regards to my two variables. My variables are hours of sleep and test scores. So what does it mean when I have a positive correlation? It means that as X goes up, so does Y, or the opposite. As X goes down, so does Y. So in this case, hours of sleep, you can explain it one of two ways, but the correlation means, so I'm going to go ahead and write out my sentence here, the correlation is positive, which means that as the number of hours of sleep increases, as the hours of sleep increase, what happens to the test scores? Well, the test scores increase as well. So I'm just summarizing what the data is showing on the scatter plot. So take a second and try this one on your own. So pause, try this, and the answer here, if you're looking at, kind of if I could draw a line in here to show the overall relationship, this is going to be a negative slope, so this is a negative correlation. So meaning as one value goes up, as the X value goes up, the Y value is going to be doing the opposite. So in this case, what does it mean? And I'm going to write just a short sentence here. The negative correlation means higher ages or older people means, I'm just going to go with older people spend fewer minutes playing video games each day. So spend fewer minutes playing video games each day. According to the data we have. So is that true in every single case? And that's something important to realize with scatter plots. Does that mean that you're not going to find a 70-year-old who if this on the graph is up here at 90 minutes, just like the 10-year-old is. Not necessarily. It's just saying the general trend is that. Correlation doesn't mean that this is true for every single person or every single data point. It just means that there is a relationship shown. In general, this is the relationship. All right, so when we talk about scatter plots show a trend, and when those trends lie in a linear type of pattern, like the one we just saw, we generally use what's called a line of fit or trend line to model the trend, to give us a more exact view of what the trend is. So a trend line is literally a line that belongs in the middle of the data. So in general, your trend line should show the general trend, show the general direction, and in general also kind of be in the middle of all the points. In the middle of your points. So kind of more officially putting out there that negative relation. So when it comes to trend lines and lines of fit, we're actually going to be creating our own trend lines and lines of fit. And if you look at this data, and you can read the question, it shows the year since 1988 and the largest vertical drops of roller coasters, of 9 roller coasters that happened to be built. Not every roller coaster, just 9 different ones that were built since 1988. We want to look at, is there a relationship in the data, and if so, we want to use that to help us predict information that maybe isn't in the table. So, looking at making a trend line, there's a couple of steps we're going to actually do, and we'll come back to these ideas as we execute them over the next minute or two here. We're going to make a scatter plot, we're going to draw a line of fit, and then to do the actual analysis, and that's what we're going to be practicing most of all, is we're going to be using our knowledge of linear equations to actually write the equations of the line of fit. So looking at this actual problem, and there is no you do on this video, or this part of the video. There's only an I do. The you do is going to come in class where you're actually going to be practicing this a lot. To do this, first thing we need to do is make sure our table is labeled, or sorry, our graph is labeled, and this is going to be the years since 1988, and this is going to be the drop in feet. So I need to make sure that on my graph I'm going to be able to fit all my points in. So I'm going to go by 2's along the x-axis. And I'm going to go by 50's on the y. Through a little bit of magic here, I actually already have the points plotted. And then to draw my trend line, what you need to realize is a trend line isn't always going to be in the exact same place for every single person. Your trend line needs to be in the middle and somewhere close to explaining the relationship between the points. So since there is no official you do on here, the rest of this problem is going to be the part of the you do. And so what I'd like you to do for the rest of this problem is you are going to write the equation of the trend line. So you may be wondering, how am I going to do that when I've got these points all scattered all over the place? The idea is you're writing the equation of your line, not an equation that's going to have every single one of these points on it. So when you look at your line, you can do one of two things, and I'm going to do both here. You can either pick a point that is really clearly on your line. So it looks like my line clearly goes through the point 2, 150. Or the other option is you look for a point that is in your data that was clearly on the line as well. And it looks like my line goes through these data points pretty well. So if I look at my table, those two data points, 12, 306 and 12, 300, it doesn't really matter which one I pick, but I'm going to pick 12, 300 so I don't have to deal with that 306 just because 300 is a little bit nicer number. So what I'd like you to do from here is to take those 2 points, write the equation of a line. I'd like it in slope-intercept form, and then see what you can do as far as using that equation. How high is that vertical drop 30 years after 1988? So that's your challenge to finish this. We'll go over it in class tomorrow.